So week 5 is using interdisciplinary knowledge to make change. Our fabulous professors are Dr. Drew Talley from Environmental and Ocean Sciences. He is going to talk about educating women and girls for the planet. Professor Jillian Schaefer from Art, Architecture, and Art History will talk about design for climate change. Dr. Frank Jacobitz from engineering will talk about design, thinking, and change making. And our very own Dr. Dominguez from political science and international relations will talk about knowledge for democratic citizenship. As usual, we will start off by asking our speakers to summarize just a little bit each of their disciplines and explain to us a little bit how they see their discipline, how their discipline views knowledge. And we will start off with Dr. Talley.
Hi, everyone. It's great to see you all. Drew Talley. I'm officially a biological oceanographer, and I'm in the Environmental and Ocean Sciences Department at USD. Boy, describing biological oceanography or environmental science is tough, but it is, among the sciences, a super interdisciplinary science. So, there's someone like me who knows more about the fishes and the animals and the communities, who works alongside someone like Dr. Jennifer Prairie, who's an amazing scientist in our department, who understands biophysics and sort of the way water moves and the way organisms get their food at a really microscopic scale. And then I also work with Dr. Beth O'Shea, who's a geologist. So she understands the chemistry and the geology of ocean environments. And so it's a really exciting field where we are constantly sort of trying to push ourselves outside of the boundaries of our own particular discipline. And hopefully, as you'll see when I give my talk in a bit, you'll see that we even push ideally well beyond just the sciences themselves.
Hi, I'm Jillian Schaefer. I'm an architect. I'm officially in the Department of Art, Architecture, and Art History. And I also run a small practice, which is based in Los Angeles. And I guess you could say that within the discipline of architecture, my specialty is urbanism. So in my practice, right now we're doing an urban design project for the Coachella Valley for a public policy group on the topic of climate resilience. We're working on a library in Mexico and also doing some small single family additions that address issues of densification in LA. You could say that architecture is a very large field, although you could say it's kind of a small community of those that are thinking about architecture maybe more progressively in terms of activism and social change. Nowadays, you can hire professionals with the expertise of building a building, but when a client approaches an architect, I think ultimately what they're looking for is a concept or a partie. So maybe another way to put it is that there's noise and there's music and architecture is the score. So I personally wouldn't consider most buildings in our day-to-day lives architecture. And I think the discipline, the expertise of architecture discipline really ranges from thinking spatially across scales, relationships that are visible and invisible, visualization, but also the technical expertise of drawing and structure and assemblies. So as a field, we're really between the sciences and the arts. So there's kind of a whole spectrum between those two poles, things that are more value engineered versus something that's more in fine arts. So I guess maybe to kind of rephrase, I would say that architecture thinks about knowledge systems often and as relationships that can be disassembled and then reassembled in order to construct new interventions. So like I said before, as a music score, you could also think of architecture as syntax or grammar in a sentence. And lastly, architecture is inherently political. So the act of organizing or drawing these relationships on ground, it's social, it's economic, cultural, and environmental. And because the architecture field, it takes a long time to realize a building, you can always say we're one step behind the contemporary moment as well.
Hi, my name is Frank Jacobitz, and it's really a great pleasure to be here today with so many new incoming students. engineers have some sort of a public image of being problem solvers, and that is correct. But when you solve a problem, you follow typically a process, and I'm going to talk a little bit about this process. But depending on the problem, you really need to integrate a variety of knowledge from many domains. Your own domain, the technical knowledge, is one part, but everything engineers work on somehow affects society. There are bridges, there are cars, and those are the most classical examples of what a mechanical engineer, a civil engineer might work on. But these devices are used by people in society, and that means we need to integrate the knowledge from different areas on how to actually make these devices usable. So if this comes to a car, you have to think about how are people using the car? How can you make sure that they're using it safely? Engineering also in the last 20, 30 years has really broadened its scope. And if I'm just looking at my work over the last 10, 12 years or so, I have started to work more and more with people outside of the engineering domain. I've worked with chemists, I've worked with biologists, but I've also worked with political scientists. And I hope you get a better understanding of why this is necessary in my presentation. So I don't want to go too far forward at this point.
Hi, everybody. You've already heard from political scientists this during our little 5 weeks together here. You heard from Dr. Crawford earlier, so I won't go into too much detail about what political science is and isn't. I think he described it as or many political scientists describe our discipline as the study of power, who gets power and how they get it and what they do with it. Other people describe political science as the study of democracy. What are the ideas and the practices and the government structures that enable democracy to function, and how have those changed over time and are continuing to evolve, and how do they look in different places around the world? So those are some ideas about what political science is. We're a social science, and so we use, many of us use various types of empirical methods to ask and answer questions in ways that can be valid for people who are very critical, right? So we have a series of methodologies that we use, and we critique each other's methods so that we can arrive at the most verifiable conclusions that we can. And those are constantly evolving. As we've talked about, the nature of scientific knowledge evolves over time. And my expertise and my specialty is in American politics. And so I've looked at the relationships between political parties and government and the organization of political parties and the way that elections work, especially presidential elections. And I also study the institution of the presidency. And I've been working for a long time on the evolution of war powers in the constitutional system. So that's a little bit about my expertise. And now I think we'll get started here with Dr. Talley, and I'll talk a little bit more about knowledge and democracy at the end.
Hi, everyone. So let me get this talk started here, make sure everything's working right. You would think after all this time with Zoom, I would be more of an expert. What I'm going to be talking about today is what it says on the label, non-obvious solutions to the climate crisis. So let me start by giving you a brief idea of where I'm going with this outline. I'll talk a little bit about climate change, not too much, but I think it's important to sort of lay the groundwork, talk about what causes it, what its effects are. Then I'll talk a little bit about the types of solutions that we normally think of, the STEM solutions to, science, technology, engineering, and math, solutions to climate change problems. And then I'm going to talk a little bit more about this sort of what may seem like a surprising way to solve this issue, and that is by educating women and girls worldwide. So let me start with this. What is climate change? This may be a little review for some of you, but there's always some people who haven't heard this before. So the sort of short version is this, that the energy from the sun warms up the earth. If there weren't an atmosphere, a lot of that heat would just go straight back out into space. But since we have an atmosphere, it acts sort of like a blanket or a greenhouse that holds some of that heat in. And I think one of the points I want to make about this is that that's not bad. That's actually the only reason we can live on the Earth, is because we have an atmosphere, we have greenhouse gases, and that keeps us warm. The problem is, of course, that as humans, we've done a good job of adding gases to the atmosphere and sort of changing what's in the atmosphere. So there's, water vapor itself is a greenhouse gas. It's really abundant, but it's not very powerful. It doesn't do much to keep us warm. On the other hand, CO2, carbon dioxide, super abundant. We're all breathing it out, and we're getting it from burning trees and from just sort of metabolism of animals on Earth. And I'm not going to go into all that, but CO2 is a big one. And then there's other things like methane and fluorocarbons, which all I really want you to know about that is many of these are things that result from human activities. A lot of those fluorocarbons are things we use for stuff like refrigeration or for manufacturing of our iPhones and our computers. Okay, so with that as background, I also want to say, so that's how we get greenhouse gases into our atmosphere. In a natural system, there's also some big, what I would call sinks for greenhouse gases. In a natural system, they get taken up, and that we often just measure it in terms of carbon, because so much, CO2 has C for carbon right in it. So we often measure it in carbon, and we say, oh, some of you may have heard us say, oh, the oceans sequester or hold a lot of carbon. What we really mean is coral reefs and other things take up that carbon that's in the atmosphere to help reduce global warming. Same with plants. When they're growing and building tissues and bark and leaves, they're taking up carbon. And so humans are also impacting these sources. You've heard about ocean acidification, perhaps, but I think most of us know that our coral reefs are going away, and a lot of the rainforest in the Amazon right now is burning. So we have increased the sources of these greenhouse gases, and we've decreased the sinks, the ways we can get rid of them. So what are the effects? Obviously, that could be like a whole course, not even just a lecture on its own. But I just wanted to put up a few of them here. What we're getting, and a lot of it is stuff that you guys are seeing right now, like the incredible heat waves. Well, heat waves are going to be more common and more long lasting with additional climate change. We're having fisheries and coral reefs going away. All of this extreme weather where you get hurricanes and tornadoes are exacerbated by this global warming and climate change effects. And none of that is to mention, sea level rise. You guys have seen in the news all the wildfires we have right now. So the climate change effects are sort of all around us, and we need to figure out ways that we can deal with those effects. And so now I just wanted to briefly talk about, and if this were a regular class where we're all in person and we could chat, I would probably ask you guys to all hey, list some things that you think of as good solutions to climate change. But I know what a lot of us would think of. I know my first thought would be, well, I look at these electric cars, I look at all these other things that people are doing to reduce greenhouse gases, recycling. Those are great solutions. So I wanted to talk about some of those and sort of give you a feel for the pros and cons of them. One of the big ones is rooftop solar, right? That picture I got is actually from our USD website. So you can see the chapel in the back there and one of our rooftop solar. We're trying to do our part to reduce greenhouse gas emissions by using solar for our electricity. And this graph, don't worry too much about the details, but what it's showing you is that we've gotten better at making solar panels. They're cheaper, they're more broadly in production. So that's the orange going down. And as the price has gone down, the use has gone up. So you can see the blue going up there. It is a really good way to try and ameliorate some of these effects. It's not perfect, right? When you construct solar panels, you're creating a lot of pretty nasty chemicals. You're using greenhouse gases to move them around and to manufacture them. So for every one of these, there is a downside, but it's one of the popular ways that we try and reduce our impact on the climate and slow climate change. Electric vehicles, as I mentioned, I mean, what could be better than that one? It's totally made of leaves. But even in the real world, when you have a regular Prius out there on the road, it's making a big difference, right? And you can see in this graph, it's just showing through time that particularly in China and Europe, although the US and the rest of the world are starting to pick up now, you're seeing an increase in the use of electric passenger vehicles. Again, it's great. There are some parts that a lot of people don't think about, like if I plug it in and I pull electricity off the grid for my car, I might be living in an area where they use coal burning facilities to create that electricity. So that part's not so great. Batteries, the creation of lithium ion batteries has huge environmental costs. So again, just wanted to stress, it's not a panacea, but yeah, electric vehicles, that's a great method. Another thing that people talk about a lot is having a plant-based diet. Eating meat and chicken and dairy products has a huge impact on climate change and global warming. And the reason is kind of captured in this graph where you see that there is a bunch of emissions that, not surprisingly, come from cows themselves, right? Both ends of the cow leave a lot of emissions. But importantly, what creates even more of the greenhouse gas is knocking down forests to make feed crops. A lot of those fires in the Amazon that I talked about are people intentionally burning acreage because they want to turn that jungle, that rainforest, into a cattle crop where they can raise cattle, and fertilizer production, et cetera. So a lot of that, it could be ameliorated by us switching over and saying, hey, let's have a more plant-based diet. And you guys have probably seen we're starting to get these Beyond Burgers and Beyond Meats. So we do have some good alternatives. And again, that is a good way to try and make a difference for this. The last one I'm going to mention here, I think it's the last one, is recycling. I'm a big recycler. I make a big point of separating the paper from the things that aren't recyclable, et cetera. You can see it here in the recycling rules. This is a USD fact sheet that they put out about, hey, make sure you're recycling right. It's not always easy. You have to pay attention to the weird little numbers on the bottom of your bottles and plastics. If you contaminate some of that plastic, if it's a pizza box that you've recycled, the whole thing has to get tossed sometimes. It depends on how the recycling works. And honestly, there are some places where people take everything you've thrown into the recycling and they just dump it straight into the trash because it's expensive to do the manpower and sort everything. So again, there's downsides and upsides to all of these, but recycling certainly is something that we think about a lot when we're doing these kinds of work. Sorry, I saw messages in the chat. I'm going to try and ignore that for a minute. So I'm about to show you guys a chart that sort of shows how much we can actually save, how much of that carbon we can sequester. And so I want to really briefly, and I am not watching the clock well, so please, Dr. Peterson, feel free to interrupt me if I start to go over, because this is something I can talk a lot about. But I want to talk about how we measure greenhouse gases, and we do it based on how much carbon something costs or saves as far as adding it to the atmosphere. The crazy thing is these numbers are so big, we talk about gigatons. So a GT of carbon, or gigaton, that's 1 billion tons, which I don't know about you guys, to me, even as a STEM person, that means almost nothing to me. I can't think of what 1 billion tons is. So I tried to look it up and be like, well, what is that the equivalent of? Well, this is the first thing I saw. Well, it's 1 million blue whales. I don't know, that still sounds like a lot, but again, it's still 1 million, and it's a blue whale, which I've never really hung out with very much. So that doesn't mean that much to me. Okay, here we go. One way that it does make sense is think of it as the weight of half of the Earth's population. So if you took half of the people on Earth and weighed them, that would be 1 gigaton of carbon. Okay, now all of that just to show you this graph. So what I want to do is look at how much, this was a study that estimated over 30 years, how many gigatons of carbon could we save by fully enacting these different things. Starting with rooftop solar, you can see that that's about 48 gigatons of carbon. Doesn't mean that much to me again, but think of it in relative terms. So, okay, 48, that sounds like a lot. What about electric cars? Well, that's 14. So in my mind, I'm immediately thinking, wow, rooftop solar, that's a really good way to go. Electric cars, sure, it's good, but it's not quite the same. Surprisingly, that plant-based diet thing is huge. That's 75. So you're looking at, not quite, but getting close to twice as much as rooftop solar. And recycling, only 6. And again, I'm saying only 6 of this huge, huge number, but it helps me figure out what's going on with where I should be putting my energy. All right, we're going to come back to that in a minute, but I want to talk about what's so powerful about educating women and girls. It turns out that is one of the best things we could do as far as mitigating global warming. And there's a bunch of reasons for that, and I want to run through those with you. The first one is just that it increases understanding, that educated women better understand what causes climate change and what might happen to them and their families because of climate change. And so people are more likely to take appropriate action and do the right thing when they know more about it. So that's a huge factor right there. The second one is earnings. Women with an education tend to earn far more money than women without an education. And that buffers them. If you have money, you can sort of buffer yourself against some of the effects of natural disasters, and you can better afford to buy solar panels, to do these different things that help to mitigate the problem of global warming. Nutrition is a huge one. Educated mothers spend more of their resources towards nutrition for their kids, tend to give their kids healthier food, and that healthier food tends to be more plant-based diet. So by having girls and women who are educated and become educated mothers, that is going to have an impact on climate change as well. This one's really interesting. Educated women tend to have fewer children, and that means lower population, so there's less of an impact on climate change. Now, this one is tricky because I want you to be really think hard about the way this one works, because a lot of people sit there and think, oh, there we go. Those people in poor countries who tend to have a higher birth rate, they're the ones causing all this climate change. That's not the way it works. One person in the Western, in a fairly well-off economically country like the US will be creating 40 times the amount of greenhouse gases that someone from a lower income country would be. So it's not all the same when you compare across countries, and by us reducing our population, we'll have an even bigger effect on that climate change issue. This one I think is right in front of our face. We often hear about how we don't have enough STEM scientists and people working on these issues like the engineering end of things and all to solve these problems. Having more women enter the STEM fields will directly contribute to solutions for climate change. More education for women leads to more women leaders. And it's really clear when you look at the data, governments with more women leaders are way more likely to pass environmental legislation. Again, that's complex. It doesn't just mean, oh, you elect a female prime minister and instantly you're going to have more climate change legislation, but it certainly is a factor. So I wanted to come back to this graph again, now that we've chatted about that a little bit. Remember, here's the relative impacts of these. if we add in what it would be to have women and girls be better educated, you can see that among these really popular and really potent ways to attack this problem, that is huge. It is way bigger. It is a place that both just because it's the right thing to do that we should be putting our attention at. So great. So I guess we send books and teachers and then everything's good, right? That's not the way it works, unfortunately. So it is the way we need to go, but there's a lot of issues. And I want to bring up just one example that I want to use to talk about this before I close out. And that is this. In a lot of communities throughout the world, including low-income communities in the United States, girls miss school, often drop out completely due to the lack of feminine hygiene supplies. It's sad and horrifying and awful. And it's a really complicated issue because there's cultural and social aspects to this issue. And so what I wanted to do was talk about just how complicated this is. So if we're looking at that problem, right? Someone like me, an oceanographer, probably isn't a ton of help directly with figuring out how to solve that problem. On the other hand, a lot of this, a sociologist, someone who studies social issues, can help us to figure out why it's so embarrassing, why in some countries, literally half the girls have their first period without ever having known what it is or what's happening. Could be about communication, right? Maybe you need to find a better way to communicate that so that the people in this society and culture don't look down on it or think it's taboo or scary when someone's having a period. Engineering, maybe an engineer can figure out a way to more cheaply produce feminine hygiene products or come up with a new type of product that would be more accessible. Maybe it's a political solution where you need someone to go and pass laws and think of ways to get money directed that way. Or it could be pure economics. Maybe the money is out there, but by an economist working with someone in communications, they can work to battle this problem. So it's a really complicated web. And I think this might look familiar to some of you, right? If you think about it, right? This is the liberal arts. This is one of the things I love about USD. It's, oh yeah, you need someone from sociology working with someone from comm studies, working with someone from over there in the School of Engineering. So I think it's a really interesting sort of microcosm of all the problems that we try and fight. And it can sound a little depressing because I'm using the example here of the Greek myth of Hercules fighting the Hydra. And the Hydra was super scary because it was 9-headed and he had to deal with all 9 of those heads. And sometimes that's the way I feel when I'm thinking about some of these environmental issues. But I actually think you can look at it in a more positive way and think of it as, yeah, what that does mean though, is that each of us can use our own skills and our own expertise to fight at one of those 9 heads. So maybe we can all work together, and I can't solve the whole problem, but I can do my part. So the fact that individual actions can lead to this big global change is what I think is so important. Also, I just want an excuse to show this picture because this picture makes me happy every single time I see it. And then finally, I just wanted to put up my information there for any of you. If any of you want to talk with me more, there's my email, phone number, web address, Twitter. So feel free to contact me. And with that, I will hand it back over. Thanks.
So I went back and forth when preparing this talk about kind of whether to present a general talk on architecture and climate. But because I'm not an expert in climate science, I thought, and because architecture is a creative discipline, I thought it'd be more telling to share a project with you, which is kind of engaging climate change. And this is a project right now in collaboration with a climate scientist and professor, Nick Lutzko at Scripps Institution of Oceanography. But I guess maybe to start, the Salton Sea is one of the areas which will be most devastated by climate change. And these effects are already becoming visible, exacerbating social inequity in the region. And this project has also evolved quite a bit since working on it last year in 2020 into kind of more of an urban research, doing planning as part of Biden's infrastructure bill. But I wanted to kind of begin this with a quote from Climates, Architecture, and the Planetary Imaginary, which I think is part of the reading that I selected in the anthology, which was published in 2016. So our conception of things like air, ocean, rock, ice, and the weather condition our engagement with them. This could mean many things for the field of architecture. Perhaps most central is the recognition that our environment is not just a resource to be managed or an externality to which we must adapt, but one of the chief figurations of shared or contested cultural values. The material that I'm kind of exploring this morning is dust, which brings materiality to some of these ascribed to climate, and they force us to think about what architecture is and does. So dust is both ubiquitous and often goes unnoticed, but it has a huge impact on climate and on society. Famously, Mary Shelley wrote Frankenstein during the year without a summer in 1816, which was caused by volcanic ash from an eruption of Tambora. We can see dust from space. Dust also has a connotation of uprooting and moving populations, as we saw in the Dust Bowl. And its pervasiveness can be associated with ideas of revolution, protest, migration, as the dust rolls in, and so on. And lastly, a lot of the dust going into the atmosphere from arid deserts come from fossils, creating a link between the present state of the atmosphere, the weather, and distant past, which gives another illustration to the phrase from dust to dust. So dust is the medium by which the atmosphere gains materiality. This is a satellite image showing the vast quantity of dust that blows off of sub-Saharan Africa. Over 100 million tons per year passes over the Atlantic, where it fertilizes the Amazon rainforest in Brazil, seeds hurricanes, and sinks to the ocean floor, where nutrients are provided for phytoplankton. These images illustrate the scales of dust, from the microscopic composition to the global scale of its transport. Where does dust come from? Most of it originates from shrinking lakes over the world, from around the world, and therefore that's the direct connection to climate change. And although the Salton Sea in California is often referred to as a sea, it's a lake, and most of the dust which blows across the Atlantic, kind of connecting this back to Lake Chad. But there are many other examples of lakes which have shrunk during the 20th century, leading to more dust in the atmosphere. So on the bottom right, in California, Owens Lake, over here, although a different scale to the Salton Sea, it has been studied as an example for the Salton Sea of how we expect the Salton Sea to change in the next decades. And of course, desertification has enormous consequences for humans, as local communities are turned into climate refugees or suffer from increasingly severe famine and conflict over scarce resources. In Yemen, civil war and global warming are combining to create some of the worst famine on Earth today. So returning back to the Salton Sea, in the past few decades, it has already experienced substantial reductions in area. So on the topic of water politics, it used to be that surrounding counties such as Los Angeles and San Diego diverted resources to maintaining the sea and sustain local ecosystems, industry, and population. But as water became scarcer, this was no longer feasible, which is why it has led to a rapid shrinking of the Salton Sea. So this is also another example of some of the kind of, I guess, skill sets of architects. So this is a kind of a cartography that I drew of the area. So for those of you who don't know, the Salton Sea is the first body of water which many migrants encounter after crossing the border. And it's also a reason why there are settlements around the sea. But in fact, in the 1960s and 1970s, the Salton Sea was a major tourist destination. and it attracted more visitors per year than Yosemite National Park. The culture at this time was quite similar to its neighbor Palm Springs, but tourism rapidly disappeared as local ecosystems collapsed. Today, the Salton Sea is home to many communities which face the dilemma of worsening dust conditions while not being able to physically move from the climate-affected region. While many inhabitants dream of leaving, the widespread issues around respiratory health mean that even those with the ability to leave feel an obligation to stay and take care of families. So 20% of children in this area are born with asthma. So there have been a number of strategies identified for suppressing dust, such as weighted gravel and nets that would stop the transport of dust. The shrinking sea is leading to rapid increases in dust emissions. So under normal conditions, the sea keeps the basin cool, which generally stops winds from flowing over the topography and kicking up dust. During a dust storm, when the cold air blows over the topography, it's able to blow over the basin and then kicks up dust. But ultimately, what this means is in the future, as the lake shrinks and it doesn't cool the basin as much, winds will be able to penetrate into the basin more easily, leading to a constant dust storm state. This is an image of the newly exposed lake bed or playa, which is a prime source of dust emissions in the future. So the changing meteorological and dust conditions are subject to scientific investigation. And so this project, which I'm kind of going to show you, this is the research leading up to it, is to construct a research base that fits into the dust storm conditions while also serving to the community as an educational space. So this now is a picture of the site. It's next to a series of citrus orchards, and the land to the east is free land on which the University of California, San Diego has already installed some scientific equipment and a small weather station. And importantly, the reason that this is cited here is the presence of an internet tower and access to utilities like electricity. But to the northeast are the views to the Salton Sea, kind of out this way, as you can see. And the kind of the massing that I'll show you from here is kind of the way that I started thinking about how architecture can engage with these larger scale systems. This is a photograph of the existing instrument and weather station, which takes periodic measurements of the changing dust levels in the atmosphere and relays the data back to scientist Amato Evan and his team. Given that dust is a topic of research, we started by studying the prevailing wind directions, both during dust storms and secondary winds during quiet conditions. So our key finding here was that dust storms mainly occurred from winds that blow from east to west or southwest to northeast. Oh, oops, sorry, I was one ahead. So this is the image. This is the image of wind direction. So you can see here, this is the site, and this is looking at the different wind directions for different kind of samplings around the sea. Okay, so we organized the building into 3 programmatic bars, one for research, one for education and community, and the third as a dormitory or shelter space for the research team. And these 3 bars then orient to the prevailing wind directions, and they create programmatic overlaps, which hybridize and inform each other of different kind of mixed interactions. And together they create, or they form a building envelope, which is then sealed by a dust membrane or outer skin. And lastly, the bars are then calibrated to curated views of the sea and also of the dust that will accumulate along the windows of the research space. And the purpose of this dust that passes through the membrane and accumulates on the windows of the research space is the creation of a stratigraphy. So just as rocks form in layers that represent changing environmental conditions, the dust that accumulates creates a record of the changing climatological conditions. So as new parts of the lake bed are exposed and and the properties of the dust, for example, color and the size and grain of dust. And as they change, so do the layers. So here you can see the climatological layers or stratigraphy and section forming around the window of the research space, which has been calibrated to wind directions. So the stratigraphy acts as both scientific data and a visualization of the impacts of climate change on the Salton Sea. So kind of in other words, the accumulation that's formed here along the windows will kind of be a didactic tool for those inside to encounter it, to see the timescales of environmental change. And of course, we kind of ran this form through simulation. So with the stratigraphy in mind, the massing was organized through live simulations using a software called Butterfly, which looks at the pressure and velocity of these winds to extract surfaces that would accumulate dust over time. So purple here represents low pressure and yellow represents high pressure. And you can also see in the form that there are eddies spiraling in the kinks formed by the bars. And these circling of the eddies will trap dust in these corners. In the plan, you can see those 3 programmatic bars that I spoke of earlier and how they overlap. The research space with 2 stratigraphies created on both sides here. The community classroom, which cuts views back from the stratigraphy onto the west, which is visually linked to sweeping views of the Salton Sea to the east. And since the research team only visits the site during extreme conditions, the project hopefully will serve as an educational and community center as well. So it would be a place where K through 12 school children from the Salton Sea could use the space for after school activities, and the dormitory space could make it possible for campouts. And it would also become a space for educational groups to travel to with interest of learning more about climate research and climate change in the Salton Sea, since it becomes a hub for plotting data on dust that's sent back to the university. This is a view of the community classroom linking together the visible shrinkage of the Salton Sea and the data along the windows of the research space. The entrance is covered by an awning to keep the dust out and punches the hole through the net. Standing from the wall near the scientific equipment, looking back through the research space and community classroom, there are views out to the sea. The research space is embedded further into the landscape in order to submerge further down for dust collection, but also to prevent dust from blowing out along the sides. So there's a scientist, Sarah Ahrens, who uses a similar technique to the net, but at a much finer scale for her research with marbles to collect dust for experiments. I guess there was also a little bit of speculation about choosing materials for interior finishes and specifically looking at salt, which has been used for dehumidifying properties as an agent for curing respiratory problems. So we've done a little bit of material research and thinking around how salt might be used as an interior finish, as a kind of a salt brick. So materials here perform not only for their visual qualities and structural integrity, but also their atmospheric effects. And then kind of to wrap up, there are just a few more renderings. This is a rendering for the year 2025. So looking from the exterior, a subtle stratigraphy over here forms along the west-facing facade. In 2025, the building provides shade and shelter. It functions as a dust storm observatory and creates an infrastructure which provides scientists with new results. 100 years later, in 2125, the building creates a record to be studied about the accelerated changes in the region and accumulates dust onto its walls until buried. Ultimately, the stratigraphy speaks to the act of scientific data collection, to the didactic purpose of the building in visualizing climate change, but also to the inevitable aspect of ruin. people will only live in the Salton Sea for so long, but the research base will eventually transform from inhabitation to observational use. So the project is kind of ultimately at the intersection of multiple timescales, the timescales of humans, which they might observe change, the timescale in which a building falls out of use, the climatological scale on which regional weather changes, and lastly, the geological scale on which all of this is recorded through the medium of dust. And that's it.
So I want to talk about the way engineers solve complex problems, and this method is called engineering design or design thinking. And I want to relate it to changemaking, which is really one of the staples of USD and the engagement that is really possible for students through the Changemaker Hub. I struggled a little bit with the subtitle. It is correct. Design thinking is how engineers solve complex problems, but it's not only engineers anymore. This methodology really has been embraced by other groups as well. And the Changemaker Hub has actually taught workshops on how to employ this method. So roughly speaking, I have three parts. I want to talk about what are complex problems. Then I want to talk a little bit about the method of design thinking. And then just like in the last presentation, I just want to talk about one of the projects I've been involved with. So a really high level way of thinking about complex problem is to look at classifications that have really been attempted by a variety of different institutions. And I'm just using the United Nations Sustainable Development Goals, which really represent problem areas of importance for humanity. And you can just go back and really think about how do some of the presentations from today fit in. And there's a climate action element to it. I will just talk really briefly about zero hunger on one of the next slides. And my project really falls into this area of clean water and sanitation. So you'll hear a lot more about that. Now, this is very abstract, very high level. So in order to make this maybe a little bit more digestible, think about what USD is doing through the Changemaker Hub. Every year there's a Changemaker Challenge, and some of you will participate in that through clubs, through your LLC courses. There's a variety of ways to get engaged, and it's actually addressing food justice in San Diego. So this is actually a challenge that is posed specifically to the USD community to really think about and be thoughtful and imaginative about finding solutions to this problem. So this is a little bit more digestible, I think, in terms of the scope. Now, a little bit about design thinking. It is a process, and it's a very loosely defined process. And I'm going to show you 3 slides on it that really just have a different level of granularity, how detailed they are. I like this really big level plot over here, which really just consists of 3 elements. Inspiration, you do need a problem to solve, you need an idea. Ideation, that's really the fleshing out of the idea that you are trying to use to find a solution, and the implementation. One of the really basic elements of design thinking is a call to action, a focus on doing versus just observing, describing, theorizing. Now, the next slide just shows this process broken down with a little bit more detail. So basically, the first topic is now broken up into empathizing. This is really understanding that the problems that engineers solve, or that you will solve, are not your own problems necessarily. You are actually working for somebody else. This could be, if you're working in a company, a customer, or if you're working, for example, for an NGO, this could be a community that has an underlying problem to solve that is theirs. And you have to empathize and find solutions that really follow their needs and are also acceptable socially, culturally, politically in the environment in which the solution eventually has to exist. An additional really important step is to define the problem very carefully. if that is not done, it is very easy to just go off in a tangent and just basically lose sight of the core of the problem that you really try to solve. Then the next one is really, again, ideate, come up with ideas, brainstorm solutions. And this is actually the point where quantity to a certain degree is better than quality. Come up with a lot of solutions. And first, don't ask, oh, is this a good solution or not? First, come up with a lot of them, then figure out which one actually has a good chance of addressing the problem, and then follow up on that. Once you do that, act, really prototype, build something, really try things out, and not only try it out yourself, let the communities for which you're working try out your solution, get feedback, and then make things better. So the testing phase really is about seeing what works, what doesn't work, what needs improvement. And what I don't like about this particular slide is this lack of some sort of a loop, that you're constantly improving until you're really satisfied with your solution. The last representation of essentially the same thing, the same process, is more engineering focused. So often this is called the engineering design process, but it has the same elements. It has basically this definition stage where you ask about the problem, you do research of what has been done before, you then imagine solutions, you plan how to approach them, and then you have this call to action where you create, test, and improve. So I hope you see that these 3 slides showed the same thing at different levels, and using also different language because they were actually geared towards different audiences. What I want to do for the remainder is actually just talk about a particular project that I was involved with, which is on assistive devices. In particular, we have been working with a community in Uganda. So Uganda is a relatively small country at the northern shores of Lake Victoria in Eastern Africa. It has a history of conflict, and there's a lot of hazardous areas in this country because mainly of the use of landmines. And despite the fact that Uganda has been fairly stable for the last 2 decades or so, and has been declared landmine free, there are actually ongoing accidents that are happening. But there's also a legacy of people having been affected and injured and have survived the actions of a landmine. And currently the estimate is that there are about 2,000 survivors. Now, the government of Uganda does not have the services, the resources to support this group. And in addition to that, survivors are often seen as burdens to their own families and in some cases abandoned. So one group, one of our partners that is addressing this challenge is the Uganda Landmine Survivors Association, which was founded in 2005, and it has really 2 elements to its work. The one is actually campaigning against the production and use of landmines, and the second is actually to create what is lacking from a governmental side, a peer-to-peer support network for survivors. And one of the focus areas that they have is vocational training. So they want to take landmine survivors who are in a relatively dire situations, often just do day jobs if they actually can find one, and give them a means of supporting themselves in the long term. So there's vocational training in a skill. This could be computer skills, this could be carpentry, this could be textile work, but also leadership and advocacy skills. And the brain behind ULSA is Margaret Orridge, who is herself a survivor of a landmine explosion during conflict in 1998. She lost her right leg, and when she told me her story, it's amazing how lucky she was that she survived and actually got medical treatment relatively quickly and could recover. And she very quickly picked up advocacy work for survivors. She started campaigning against landmine use, and she has been recognized by many institutions, including the United Nations, for her work. And she was a woman peacemaker at USD in 2014, where she had the chance to interact with faculty, students, and the USD community as a whole. So she basically brought the issue of landmine survivors and their inability to use latrine toilets to our attention. So latrine toilets are basically holes in the ground. They are the typical toilet type that you find in Uganda, and they are difficult to use because you have to crouch down. And if you're missing one of your lower limbs, you cannot maintain stability. And it would also be very, very difficult and very work intensive to just do this with a single leg. This has safety issues. There have been rapes because people just went off into the woods and released themselves. There have been animal attacks. And what I really like about this particular project is that we are looking at a problem that is completely defined by a community partner. We are not coming up with a solution to a problem that we think we have observed or that we imagine exists. It is actually a recognized problem by our partners that has been brought to us for input, for ideas, and for potential solutions. So we really followed this process now. So we came up, we had the definition of the problem. We now came up with some ideas. So these were actually some basic ideas that we followed up. We had this, this focus on action of building prototypes. So we have a folding chair solution, we have a collapsible box, and we have a walker solution. And then we basically took them back to Uganda, and we started talking to communities. So here we are in northern Uganda, in Lira, in a community center that is basically helping people with disabilities, so landmine survivors, but all forms of disabilities. And we really just asked them to kind of evaluate our solutions. And so the first prototype, the folding chair, there were some strengths and some weaknesses that were being mentioned. So it's light, it's foldable, it's easily to transport. But it would have problems on muddy surfaces. It would potentially sink into muddy surfaces because of its legs, and it has a perceived lack of stability. And it is actually a stable device the way it was designed, but sometimes it is not just about the technical statement that, yes, this is stable, this can support your weight. It's also the appearance of it that matters. And when we presented our solutions, this was always the one that was regarded with some, questioning. Is this really stable? Is it safe for me to sit down on it? The second prototype, the collapsible box, the strengths were stability. It's relatively easy to make because it consists mostly of straight cuts. It's collapsible, but it does come with a higher weight, but that also implied more stability. And it was typically the one that everybody was willing to try out first, which was kind of an interesting observation. And then the third one was a walker, which has basically multiple purposes. It can basically help in the walking, but it's also a device where you can turn around and sit on it. The weakness here is really that it requires a fairly complex motion by the user, and that was actually the biggest point against it. We also, when we were in Uganda, we looked at existing solutions. So what has been done in the past? So Margaret's father, actually, when she was released from the hospital, they found basically she cannot use the toilet. This was kind of some sort of a panic moment. So they came up with a very simple solution using a jerry can. USAID has built pit latrines and devices at a vocational school that we visited, and also we visited a children with disabilities hospital that has a number of seats available. And again, they are shown here. You can kind of see that they have features that were very similar to what we came up with. There was a lot of observation and feedback. So stability was the top one that was always on the top of the minds of any potential user. And again, one of the observations is it's about the appearance potentially of stability or instability that mattered. Portability was mentioned as very important, and the ability to actually clean the seats was very important. We also saw that based on ability, based on injury type, there is no single best solution. And one of the advantages of the solutions that we have provided is that they can be tailored to, for example, different heights of people, different ability levels. And overall, we thought that the collapsible chair solution was the one that there was a consensus on, that it fulfilled the requirements of the problem in a most complete way. There was also a lot of non-technical feedback, and this is where the domains of knowledge really come in. It's about cost. How do you actually finance that? So this would be an economics question. It's about material science, what materials are good, and what kind of skills are there to work with these materials. There is, well, this is more social, there's the problem of stigma. The seats should actually hide their primary purpose, because people do not want to wander to a communal latrine in their village with something that shows that this is exactly what you're doing right now. And there's the question of justice. Who is actually allowed to use the chair? So people were saying, oh, you know, this actually makes my life easier. So you could say, if you're able-bodied, you are not entitled to use it. It's really there for those who rely on it. But how about older populations? And when you talk about older populations, do you go by age, by ability? So there is also this question of power. Who decides how this device in the end is used? One element that we really enjoyed in the work that our partners providing is what they call the livelihood support program. And it's a key element of also to actually help landmine survivors overcome the disadvantages that are placed in their life through injury, through economic disadvantage, through the lack of training and skill building. And it's very similar to Drew Talley's argument that education, additional education, is actually a solution to many problems. And here the idea was, let's train these survivors, and often they're young individuals that have grown up with this disability, but eventually are not supported by their families anymore. And the idea is to give them an education that, in our case, actually involve the construction of the assistive device. And that gives them more of a feeling of hope, of having a future, so that they can contribute, so that they can first actually make a living for themselves, potentially contribute to their families, and reintegrate them into the workday, everyday civil life, and basically give them back dignity in their lives. So the last step was really to build, or to actually implement that. And for that, we partnered up with another partner, Ave Maria Vocational School in Lira. So it's in northern Uganda. And this is a vocational school that provides a variety of different training areas. So there's the computer, secretarial type training. There is woodworking, metalworking training. So this is very much carpentry, very traditional skill building. But there's also farming training. And one of the things I really enjoyed while I was at the school was the community that they actually provided. So when people were just in their off times, they would actually sit together, they would sing, they would talk, there was a lot of curiosity about us, where we are coming from, why we are doing what we are doing. And most of you are about to move into a dormitory at USD. The lower left picture actually shows the dormitory at the school, where they had about 50 beds per room in an equatorial climate. So it was pretty hot and humid in the building. So those were some drawbacks, or some conditions that are probably not too enjoyable, but the advantage is it costs about $100 a month for somebody to get educated. And this includes everything: the tuition, the room and board. The only thing that is excluded is the transportation to the school. So we trained, we supported actually through the livelihood program 2 students. They started their carpentry training about a month before we arrived. Here you see actually one of the USD students, Shannon, actually instruct in the use of power tools. One of the things that is also really interesting is that we were the first to actually use power tools. The circular saw that you see here was actually provided in the past. There were no instructions. There was a used device that somebody had just given them, but there was no training involved. And that basically meant it was just sitting in a corner, packed up without actually seeing any use. So that was kind of an interesting element as well. The other thing we did is we did not only work with the students, we also worked with their instructors. So they were just instructed on how to build this device. We talked about improvements before we started actually building this particular implementation. And the idea is that they just that they incorporate this as an example of what can be built as they're going through a carpentry training program. And our goal was to actually build a prototype within a week at the school. We actually accomplished that. And we really had some great lessons learned. The first one is really work with a partner to identify needs, goals, and constraints. And that's why it shows the empathy paper as some sort of a reading, as an introduction. It's really important to learn to understand the group that you're working with as you're solving problems. The second one is don't rush creativity. So when you're coming up with solutions, do not go with your first thought. It may turn out to be the best, but it may also turn out to be the worst. Don't rush this process. Really take your time. And this was something where we had the luxury, because there was typically a year between different trips to Uganda. So we really had the idea after our first trip to think about what could our solutions potentially look like, then select the subset of 3 from this larger set of ideas, and go from there. Rely on diversity. There are many ideas that I would never have had without talking to others. Diversity is your partner in any complex problem solving. Lean towards action. Don't just keep thinking about more and more solutions. At some point, really try them out, build prototypes, see how they work, and interact with your partners on how they work, how they perceive them to be working. Be mindful about the impact of your work. So we had discussions about who gets to use the devices and so on. So this is, again, areas of knowledge that are very different from a typical engineering program. And I think the central thing is only get involved if you can commit to a long-term involvement. So this is relationship building. People really need to understand that you're not there just to take some pictures in a single trip. Come back, talk to people more, come back again, work with them. It's really important to have that long-term engagement. And one of the things that when we came back and we talked about what we had seen, experienced, reflect on how changemaking is actually changing you. Because I think that is probably the single biggest impact that any engagement that you will have in humanitarian work, the Changemaker challenge, there will be a change you will be affected by it. It will change you. And the last recommendation, this is really not necessarily something that came out of our visit, is get engaged early. Use your first year at USD to think about what kind of work you want to do. And if you find something that really fits your passion, go for it, because then you have really multiple years in order to really have an impact. So thank you.
In many ways, I don't even know what to say, being the last person to go in our 5-week course here. I'm really grateful for all of the attention that you've all paid to all of these presentations. And I was, before we started today, I was reflecting with some of our faculty, one of the professors asked me, so how's it been going? And I thought it was, I think it's been a challenge. I think thinking about the nature of knowledge and the way that different academic disciplines and ways of thinking about the production of knowledge and the use of knowledge and how knowledge evolves over time and how knowledge is socially constructed and how we can use knowledge to make a difference in the world. I think that's been a really ambitious question to address in this 5-week class that we've had together. And so, I'll be interested to talk to some of you during discussion this week, and I'll be really interested to see how you've reflected upon all of that, because listening to these classes, I've definitely had a lot of thoughts about what it is that we're all doing in a liberal arts education. But just to wrap things up, I'm going to talk a little bit today about how information and knowledge are particularly relevant to democratic governance. Some of these terms, you never know how people are going to define terms. So I'll just go ahead and say that when I'm talking about democracy, I'm talking about government by-in for the people. And yes, I'm aware that there's another definition of what a good government could look like. You could say a good government is a just government, or a good government is a republic, which just means a public thing. Government for the people is actually synonymous with the original definition of republic. But the question that motivates my few minutes with you today is, does it matter to democracy whether voters and participants and citizens and the people who live in a democratic society, does it matter whether people are factually informed about the world around them and about their government? And perhaps unsurprisingly, my answer is yes, absolutely. It matters a whole heck of a lot that people are informed. And that's why education is so important to democratic life. And so, we can begin with, okay, when we're talking about knowledge and information and democracy, what do we mean by that? What specifically do I mean by having an informed public? And there would be various ways to answer that question. In some of my classes, sometimes I'll do a little quiz and I'll ask you, who's the Chief Justice of the Supreme Court, or who's the Speaker of the House, or, what's the threshold to override a presidential veto? And basically the bottom line to such quizzes is that most people can't answer those kinds of questions. They're basic civics questions that a lot of people do pretty poorly on. But when political scientists, social scientists set out to measure knowledge and the knowledge that might be relevant to democratic governance, we can think about it as kind of falling into three categories. The first is that kind of civic knowledge, like how does a bill become a law? Or how is your city governed? How is your city government elected? What are the rules of the game? And that's the kind of knowledge that can be acquired in basic high school civics classes, in political science classes. Introduction to American Government covers a lot of that. And then also just in the course of civic participation, and in, if you don't acquire that kind of knowledge in school, you can get it other ways. Second kind of knowledge is substantive, like what is climate change? How much money does the United States spend on its military? What happened in Afghanistan that we're leaving there now? What's an abortion, right? What's going on? And then a third type is, who are the people that are involved in government and politics? Who represents you at various levels of government? What is a Democrat? What's a Republican? What are the differences between them? So an informed citizen, and if we were all collectively an informed citizenry, we would want everybody to be able to pass a simple test on all of these categories. So, why does it matter? I'm going to give you several arguments or several pieces of evidence and reasons why it matters that people, including you, including me, including everyone who lives in the sort of democratic world, it matters that people know some basic information in each of those categories. The first reason, and the most practical one for you, is, if there are things that you think are unjust in the world, you probably, you should go forward living in a democratic society saying, I can have a role in changing these things that I believe are unjust. There are ways in which collective action, government action, can address and remediate the injustices and the problems that you see in the world. Being informed really matters. If you think that there's some way in which you want to participate in making change in problems that you think are unjust. More theoretically, representative government, which is what we have in the Western world, right? We have representative government where we elect people to make decisions on our behalf, and then we all abide by those decisions. Representative government requires that the people who make the laws are capable, and that, at least in theory, having more and better information can help us, the participants in democratic governance, the voters, help us select more capable people. So yeah, we don't have to know everything because our representatives are going to actually do all the lawmaking and going to administer the laws, but we should choose capable people. And so we need to know at least just enough to do that. And when they do a terrible job, we really ought to hold them accountable, or when they do a good job, we ought to leave them in power. And so information also helps us, the voters, critically evaluate the performances of the people who are wielding democratic power on our behalf. And it's not just that, that some people need to be able to have the information to participate actively and in an informed way in governance. That information needs to be spread broadly and equitably. A broadly and equitably informed citizenry assures that the public will, like what we're all going to do together, is fairly determined, and it helps to ensure that we all see the government as legitimate. And if there are situations where some people know a lot more about how to turn the gears of government to their own advantage, they rest assured that they will do so. And then there will be asymmetries over outcomes, and some people will get the goods of government power, and others will be shut out of that power. And so it's, if we want government to serve everyone equally, then information about government and about politics also has to be spread equally. So, got a little problem with my text there, but knowledgeable citizens are also better citizens for a lot of other reasons. One is that people who know more about government, who know more about the substance of politics, who know more about the people involved in politics, tend to be more tolerant. And tolerance is a key democratic value, a willingness to permit the expression of ideas or interests that one opposes. And people who are more knowledgeable, there are many studies that indicate that knowledge helps to increase political tolerance, which is one of the core values that allows democracies to function. More knowledgeable citizens also participate more often. And so, one way that we measure that in political science is called voter turnout, right? Voter turnout is the percentage of the eligible citizens or the eligible voters who turn up to vote. And high equitable turnout is good. It is a public good. It means that politicians have incentives to represent more people rather than just representing those few who show up to vote for them. And the more people know, the more likely they are to turn out. And the more broadly that knowledge is spread in the population, the more a broader variety of different types of people turn out to vote, and that results in better representation. Thinking about how people form opinions, there's a whole field of study devoted to how people form attitudes. But political attitudes are things like, do you have an opinion about abortion? Do you have an opinion about what should we do about climate change? As you might imagine, knowledge is relevant to forming opinions. And people will give basically random answers to questions about political affairs if they don't really know anything about them. And that shows up in polling. But the more people know, the better their opinions are, and the better polling and the better other measures of public opinion are to informing our elected officials about what it is that they should be doing on behalf of the public. So basically, an uninformed public is not great. If we do, and we do have an uninformed public, that can distort our debates over public policy because people aren't operating with correct information. And there really is correct and incorrect information. And certainly there are a lot of different ways to define what correct is, but you can know it when you see it. There are some truths and some lies out there. And incorrect information when it comes to making laws and using force and using the power of government over people, which is what government can do. When that is ill-informed, it can cause real problems, right? It can cause real harm. It can cause loss of life. It can cause us to fight perhaps wars that shouldn't be fought. It can cause people to die of diseases that perhaps they shouldn't be dying of. It can waste money. It can lead to just inefficiencies in the distribution of resources. So a poorly informed public is not going to produce the best government, the best public policy that could be produced. You know, we've talked a little bit in this class on occasion about conspiratorial thinking, and certainly there's more to learn about that. But conspiracy thinking is a particularly bad kind of thinking and a bad kind of information processing for political affairs. Conspiracy thinking is the idea that there is some small group of people that is operating in secret and that is really running things, right? And there's a, you know, QAnon is a conspiracy theory, and the people who think that the moon landing was fake, that's another kind of conspiracy theory, right? So there's various people who think that vaccines will really give you autism or create some kind of mind control, right? Those kinds of conspiracy theories about vaccinations are particularly bad for democratic government, because that kind of thinking creates both unfounded and uncorrectable distrust in institutions. Once someone moves down a path of conspiratorial thinking, it's very difficult to bring them out of it. And you can't argue with it, because you present, oh, these are the facts from all of the people who've done a really good job compiling all the facts for us, and they won't engage with that. They can't be persuaded. And democratic citizenship is about being open to persuasion and looking for you know, the best truth upon which we can make public policy decisions. Conspiratorial thinking also specifically delegitimizes democratic institutions, especially legitimate political opponents and our system of government. It very often involves demonizing a group of people, dehumanizing a group of people, demonizing scientists who are just making up climate change and vaccines in order to make money on their own in some way that you can't actually point to. You know, demonizing immigrants as being the source of disease, right? Demonizing a group of people makes it easy to use the state to commit violence against those people. And it can cause people that, you know, conspiratorial thinking can cause people to opt out of democratic participation, say, oh, well, we can't affect anything because everything is really run by a small group of secretive people and they're really in charge, so why participate? So people can opt out and therefore their opinions will not be registered in the system. Or they can favor populist dictators who listen to who feed their complaints and then would sort of get rid of democratic government in favor of populist authoritarianism. So an uninformed public is bad. A misinformed conspiratorial public is very, very bad. So people who are, looking at American democracy today and looking at the prevalence of some of this conspiratorial thinking are very concerned, right? This is not just an idle set of problems that we confront today. On the other hand, it's really hard to be actively and accurately informed. It's a process that you have to learn. You have to learn to be informed and you have to work at it. And there's no particular reward for it, right? Being a good, well-informed, participating voter is not something that anyone's ever going to give you a gold star for. You do get a sticker, but literally that's your only reward. So it's hard, right? You have to do a lot of work and you have to know a lot, right? You have to, if you want to participate actively in conversations about government, you should know some economics. You should know about supply and demand and wages and the labor supply. You should know about biology. If you're going to participate in conversations about vaccines and mandates and public health, you should know a little biology. You should know some geography. You should know about other countries and the way that other countries see politics, governance, science differently than we do. And you should know about your own government and about the law, right? There's kind of a lot to know in order to be a fully informed citizen. And, again, going to this idea of a liberal arts education, It's not all just what you learn in a civics class. Being broadly informed about the world in all of your classes will help make you a more informed participant in democratic government. Just to go back to civics for a moment, the structure of our government in particular makes it hard to be informed because we have what's called a federal system, right? Where we have a national government located in Washington, D.C., and we all elect representatives to that. And then we have state governments, and we all elect representatives to Sacramento and governors in every one of the 50 states. And then we have city governments and county governments, and there's water boards and there's school boards, and they're all different. And we elect different people to run all of those institutions and make different kinds of rules. And so power is divided in the United States, and it doesn't have to be structured like that. Not all countries around the world have that kind of decentralized federalism, but we do. And when we think about why Americans, on sort of tests and that kind of thing, we don't know as much about our government as people in other countries, or we don't participate as much as people in other countries, that's one of the big reasons why. It's because actually it's pretty hard. It's hard to identify the part of government that is making a decision. Like, okay, you feel safe drinking your drink, I feel safe drinking San Diego tap water. Like, why? What systems have produced drinkable, potable water? When we flush the toilet, where does that water go? What happens to it? It's complicated. We also have what's called a submerged state. That is, many of the parts of government that are essential to us are performed without us knowing about it most of the time. Most people had never heard of public health departments before February of 2020. I've got a funny little sign here, but you do see people saying things like, keep your government hands off my Medicare. Medicare is like the quintessential government program. It is funded by all kinds of taxes, and it was a cornerstone of Great Society programs in 1960 that really built up the size of government. Like, it's a government program, and people don't necessarily know that. How does trash pickup work? How does road maintenance happen? How are student loans related to the government? So there's a lot about the way that our government is designed that make it hard for people to attribute it's the way that it interacts with their lives with who's responsible. This isn't working for me, but there's potholes on my street. Why is that? How come I can't get that fixed? Who do I talk to get that fixed? Right. So, by definition, effective government is fast, efficient, and invisible. But if it is, then it's also hard to credit the people who are doing a good job administering it, or figure out who needs to change. And who to hold accountable for problems. And of course, we've talked in this class about the media and its profit motive and the way that it offers us many exciting distractions from public policy. Sports, if you turn on the news at night, you get sports and weather and infotainment and, packaged news stories that really are paid for by advertisers, and you get people giving opinion, and people stoking outrage. And there's this, feedback loop that we've talked about in this class between how much we want to be entertained and how easy it is for the news media to give us entertainment rather than sort of hard news type information. And of course, there are some people who benefit from spreading rumors and disinformation, and media companies are some of those. Organizations like Facebook, or companies like Facebook, make a profit off of the volume of people that spend time on Facebook spreading rumors and disinformation. And they don't necessarily have a financial incentive to stop that spread. So just to sort of summarize where we've been here, there are really good reasons why we should want an informed public. There are really good reasons why we should want to avoid having a misinformed public. And it is also at the same time legitimately difficult for us individually and collectively to be informed about public policy and about how government works and about what we can do to make our country and our state and our city and our nation and our community a more just place. So, I'll conclude with some of the lessons that we've talked about in the course of this class and some that we would talk about in a political science class, what does the research tell us that you can particularly do and that we can all do to become better informed and to become, the kind of participants in democratic life that can help actually make this a better place. We've talked about the fact that you need to be omnivorous and you need to be skeptical and you need to think about how to get news and information about public affairs from multiple credible sources. And that does mean eventually you're going to have to trust. You're going to have to decide, I trust this institution rather than that institution. And it is entirely possible to assess the credibility of your information sources. It requires a little bit of work on your behalf, but it doesn't require that work on an ongoing basis, right? You could do a little research project and compare the editorial policies. Does this news organization, do they have editors? Do they do corrections when they get facts wrong? Do they list their journalistic standards? Have they won awards for journalism? There's ways to assess the credibility of your news sources, and you should do so. You should be careful to distinguish between factual information and opinion. And sometimes it's labeled and sometimes it isn't. And sometimes the two are mingled together. And it's, if there's one skill that you can learn, these are two different kinds of skills that you can learn across your curriculum in whatever you decide to major in and whatever classes you take. Think about how you can assess the credibility of the sources of information that you're taking in, that you're believing, and how to distinguish fact from opinion. We've also talked in this class about how to be aware of your predispositions and understanding that your predispositions and the way that you look at the world, you're going to want to take in information that confirms those predispositions, and it's going to affect, those predispositions will affect your memory, they'll affect your cognition, and they'll affect your understanding of the world. And so being a little self-critical and thinking about how that's affecting the way that you're looking at political information can also be a really useful tool, because politics is a place where those predispositions really do affect how we understand the world. And then finally, I just want to remind you what you may have picked up in a high school civics class, and that is that efficacious participation is your right and your responsibility, and it requires that you inform yourself. And unfortunately, that's not necessarily an easy thing to do. It's not an impossible thing to do. It's an ongoing process. You have to do it on your own terms, and you have to find ways to do it that fit with your values and that fit with your time constraints. And you have to think about it as something that you're going to practice throughout your life, that being informed about the whole world, about changing economics and changing science and changing social norms and changing social values and learning about other cultures, right? All of that lifelong learning will help you become a better sort of lifelong participant in democratic life. And particularly about government, you got to think about, I see a problem in the world. Who do I talk to? What officials can act to help solve that problem? And who represents me? And how do I talk to that person? Because they're the one who has an incentive to represent me. A lot of people are like, well, I don't like how some of those senators in other states are behaving. It's they're the problem, and they're not giving me the public policy I want. If they don't represent you, they're not going to listen to you. So, you need to think about who represents you and how do you get them, how do you use your influence as a voter to get them to do what you want them to do. You're going to have to do research when there's something that you think is unjust in the world, when there's a problem that you really think needs to be solved. You have to think, okay, what specifically do I want to have happen here? What bill do I want them to vote for? And there's a little bit of research to be done there. And it's a social process, that elected representatives have incentives to listen to you, their constituents, but they, you're just one voice. They have a lot of constituents. They're going to listen to you more strongly. They're going to pay more attention to you if you give them, if you bring some friends with you, right? So there's sort of a hierarchy of how much you can do to try to affect your elected officials. Voting doesn't communicate that much information, but obviously voting is first. Email is better than nothing. A phone call is better than an email. A visit is better than a phone call. Protesting can be a big source of change, but it's certainly not going to accomplish everything all on its own. There is evidence that after the large Black Lives Matter protests last summer, that in the places that had large protests, police violence went down, at least for a time. So that there was some influence of those protests. But what those Black Lives Matter protesters were looking for was systemic change in the reduction of police violence against Black people and other people of color, right? They're looking for changes in policies. They want police to be held accountable. They want to stop that behavior. But those policing policies, aren't going to change just because of some protests. The police can hunker down and ride out people's loss of attention to criminal justice and policing issues, and people will go back to their everyday lives and stop protesting, and the police will still be doing what they're doing. But those policies that govern policing behavior are set at state and local levels. And so if you want to be a person, if you cared about those protests, for example, and you want to be a person who participates in making that change over time, you have to, that requires sustained attention, and it requires thinking about how those rules are made. So for example, in 2020, there was a ballot initiative in the city of San Diego that was passed where the people voted for creating a citizen oversight board with subpoena power to oversee the police department. But that wasn't the end of that story, right? The city also has to now implement that. And there was a proposed ordinance to implement that referendum that many of the Black Lives Matter protesters and organizers found was really problematic, and it was going to undermine that ordinance or undermine the referendum. So the city council is now still working on how to write an ordinance to implement that initiative. And so, there requires to get the city council to put in the strongest version of that ordinance requires, as Dr. Jacobitz said, listening to people on the ground and the people who are active and following their advice about, okay, what should I say to my city council person? If I call them on the phone and tell them, what I think should be in this ordinance, what do I say? Like you have to do your own research, but you can also rely on citizen groups to help you do that. When you're thinking about political participation, you have to understand that there are 330 million Americans, all with their own opinions, and that representatives have their entire careers to think about. And just because you wake up one day and decide to make a phone call doesn't mean that you're necessarily going to get what you want. But it is possible to make meaningful change in politics, government, and the law by staying informed and staying involved. And the easiest place and the best place to make change is closest to you, with your own representatives, where politics is personal. And you begin that process by being accurately informed about public policy, about politics, and about the processes by which rules are made. And also by being a person with a liberal arts education, with a commitment to learning throughout your life about the problems that confront your community, and all of the different potential solutions to those problems. I'm going to pull up some of the questions that you guys have been asking in the chat as we've been going along. And, someone asked, do you see a future where as sustainability increases, so will consumption, essentially filling that void? Is there any real, I think the question is getting at, is there any real way to make a difference in this problem, or are we, will sort of capitalist consumption always continue to make it worse?
Well, I think that's a great question. And clearly some of that will happen, that as you elevate people's income, they can afford to buy more iPhones and more, luxury goods that increase greenhouse gases. So that's certainly something that we need to watch for. But I also think it's pretty clear, and has become more so this summer, I think, for a lot of folks, that climate change is not really something to be debated anymore. It's something to be addressed. And that, as you know, it's constantly a race with trying to get technological solutions that will fix these things. But I think honestly, the real benefit is working towards social solutions where people recognize that it's in their own best interests to do less as far as creating greenhouse gases.
There's a political science perspective that would say that the individual, you know, sort of like putting everything on the individual to buy an electric car and only eat plants is probably not going to be enough to solve these problems, and that government action is going to have to be taken. And there's you know, not just the United States government, but governments around the world working together, and that there's really a lot of politics involved in climate change, in both making it worse and in potentially making it better. So I'll just throw that. You talked about the first question I have here is, on average, how much research goes into planning and creating the design, and what is the approval process for a design? So when you're talking about a building like the one that you described, you know, what does that process look like?
Yeah, great question. There's kind of two answers in that question. So how much research that goes into a project really varies on the project. So I have clients, usually single family resident clients, who know exactly what they want and will just do a few studies, but usually larger clients allow for more research before solutions. So like working for corporations or governments or kickstart projects like the interdisciplinary grant that I presented. So before teaching, I worked for a project for Google's R&D, which really began with an open-ended question, which was just, what is the future of work? And through extension of that question, like, what is the future of the workplace? And you can kind of imagine like what some of those answers might have looked like, since we've been spending the whole year on Zoom. So the workplace looks like how it does at home. So that's that was a research question they gave us like 2 years ago. But so something like that would require maybe like a more rigorous study of the history of the workplace. So we studied mid-century office buildings, and we essentially broke things down into a kit of parts, and then we reassembled them into different design possibilities, and those were all options for the client. To answer the second question about realizing a project, I was really grateful for Professor Jacobitz describing the design thinking and the process for realizing buildings, because as you can see, there's just like so much work that goes into building a project. And in order to do that, yes, there's a permitting step, which requires a drawing set after these schematic design decisions are made. And that's the step where you detail all of the drawings. So you submit plans, sections, wall sections that abide to building codes and zoning. And all of that goes to the Department of Building and Safety, who approve the design. And all of this is happening kind of in addition to the contractors who are going to construct the project. And they start bidding on the job based off of the materials that are available. So as you can see, there's just a lot of work that kind of goes into all of this, but I hope that answers your question.
And then for Dr. Jacobitz, you know, it was really cool to see that USD students, to see them in your pictures there. Could you tell us a little bit more about how students got involved and how those projects were financed?
Yeah, gladly. I think it's really individual. So there is not one answer that fits everybody who got involved with this project. I think what students had in common is they were interested at a relatively early stage. So I think all of the students who were part of the Uganda project from engineering, I knew by the sophomore year. So, and it's important from a knowledge point of view, because you still gain domain knowledge to actually build a device and make sure that it's actually sturdy. But you can also then start planning what kind of classes should you take first from the core. I think taking a political science course early for this project is really, really relevant. So students could basically adjust their curriculum a little bit. And then typically the trips happened during the senior year. So they basically built up, they have parts of the sophomore year, all of the junior year to kind of get ready, think about the designs, implement things, and then basically travel in the senior year. For the financing, we typically traveled during the intersession in January for about 3 weeks, and the cost is somewhere between $3,000 and $4,000. And that's always a big thing, I think, from all the faculty involved who were really thinking, okay, how can we make this affordable? Because we don't just want to have students who can just basically pay $3,000 or $4,000. So we have been reaching out to donors. One of the trips was completely financed for everybody by an anonymous donor. That's not happening every year. One group of students entered the Social Innovation Challenge. So they basically became familiar with the project during their sophomore, early junior year. They then basically worked on the designs and entered this in the Social Innovation Challenge. That basically gave them the funds to support the travel. In one case, we wrote a grant to an organization that is specifically interested in skill building in underrepresented groups. So the whole idea of working with landmine survivors and giving them an education as part of the project really resonated with them, and they basically financed one of the trips. So it's really some sort of it's different every single time, but we always have been successful, which is really nice.
There was a question about for me about my my talk. How do we enforce the community to strive to educate themselves and become more properly informed, especially when it comes to politics? And that is, you know, I think that's really a key question. I think it probably be, you have to remember most people don't go to college, right? Only maybe a third of the very lucky population of the United States will go to college. In many colleges, if not most colleges, there's no requirement that you take any kind of a civics class. USD has no such requirement. And so, you know, to be informed and to encourage that kind of information, I think it's really a public policy question for the high schools of the United States. And it's tricky because there are, you know, education and, you know, should you be encouraging people to learn about the problems in their community and to see, you know, see things from other people's perspectives? That's a political question in and of itself. And there are, you know, moves to make it, there have been moves by state legislatures in this country to make it so that high school teachers cannot tell their students how to register to vote, cannot tell their students to write a letter, you know, how to write a letter to their member of Congress or to their city councilor, right? Hopefully that's not the kind of, you know, civics classes that you got in high school. Hopefully you got one. But you know, people who are holding power really don't necessarily always want there to be more informed, educated citizens. So it's a very complicated question, but I think the answer is basically you need to instill a comfort and a set of democratic values in the public schools of the United States, because it's harder to address after that. Certainly, if you are interested in developing those skills, political science is a place where you can do that. Question for Dr. Talley, you know, and this question is also a political question. Are there, Dr. Talley, are there other causes of the emission of greenhouse gases aside from human activity, or is it primarily only a human activity that's causing this?
Yeah, that's a great question, a really common question, I would add. And honestly, yes, there's a ton of things that contribute greenhouse gases. As I said, it's a perfectly normal and natural cycle and stuff that is what allows us to live on Earth. But overwhelmingly, there is just ample evidence now that this is a problem that is caused by humans. We're very clever, and we have figured out, as the clever little monkeys we are, we now know how to do a lot of things that, I mean, essentially what you can think of it as, what I often think of it as, is that CO2 that we're releasing is, when you think of fossil fuels like coal and oil, those are all made from prehistoric, right, long millions of years ago, plants and animals that died. Those plants and animals had a bunch of carbon in them. When they died and that got buried, we considered that a sink. So that was good. We had a lot less CO2 in the atmosphere. When you drive your car, I should say when I drive my car, that CO2 I'm releasing is basically energy from the sun that was stored by plants millions of years ago. So you're sort of releasing fossil CO2 back out into the atmosphere. And again, it's not just CO2, that is the one that's super abundant and pretty strong. But a lot of these other gases, like some of these gases that get created when smog, just the stuff out of the tailpipe of a car or a factory, gets exposed to sunlight, it creates some greenhouse gases that, even though there isn't a bunch of it in the atmosphere, it is thousands of times more powerful than CO2 at trapping heat. So ozone is a good example, right? Ozone is, you take smog, you add sunlight, you get ozone, and that is a super powerful gas. So yeah, unfortunately, I think we can pretty much almost 100% blame it on us.
I thank our faculty today, Dr. Jacobitz, Dr. Schaefer, and Dr. Talley. Yes, it is such a depressing note to end on, but if you want to leave on a positive note, the education that you're going to get starting in 2 weeks at USD will help you to develop the tools to help you, participate in solving this problem and other big problems that confront us. And I'm very excited for you to begin your education in college, because there's so much to learn about the world, and there's so much that you can do with that knowledge. So thank you so much for hanging out there for 5 weeks with us and thinking about knowledge in your liberal arts education.